Okay, so this is Notes 1, Basic Probability and Simulations. Remember, this unit is all about probability, okay? So it says probability is all around us. It's in everyday life, games, world events, or inherited traits, okay? So everyday life could be the weather, okay? People in the weather industry will make predictions on if it will rain next week. Okay, that is the probability. They're saying, okay, based off of previous data, we're going to say most likely out of this and this is going to happen. Okay, games. Anyone think of a game where we deal with probability? Poker? Okay. Maybe something a little bit more school appropriate? It's not school or poker. I wouldn't say Go Fish, no. Uno? Okay, no. What about the game Rock, Paper, Scissors? Okay, rock, paper, scissors. You would think, what's the probability, okay, that your opponent is going to pick one of those? 1 out of 3, right? There's 3 options, rock, paper, scissors. Okay, what about probability in world events? World events. Elections. Right? You guys should all have these answers, right? You copied down the notes yesterday? Elections. What about inherited traits?
Being ginger.
Eye color. Being, okay, sure, hair color, right? A ginger hair color, red hair color, yes, that's probability. Okay, eye color specifically, let's say we're talking about brown eyes, green eyes, and blue eyes. What would be the probability to get one of those 3? Ignoring all the traits from parents or whatever. I'm just saying if you only had those options and they were all available to you, what would be the probability? 1 out of 3. Okay. Then it says, what is probability? So it says outcomes are governed by chance, but in many repetitions, a pattern emerges. Guys are scaring me how many of you are writing this down. Didn't do anything yesterday? You just relaxed? Okay. Mathematics help understand these regular patterns. So first part is definition. So sample space. Sample space is all possible outcomes. Okay. An event is a desired outcome or a desired set of outcomes. Notation, so the probability of an event A. So the probability of event A is written as P parentheses A. Probability of A. Okay. Range of probabilities. Probabilities are events that are between 0 and 1. Or think of it between 0% and 100%. Sum of probabilities is the probability of the whole sample space is 1. So the entire sample space equals 1 or is 1. Okay. So there's 2 types of probability. There is theoretical and empirical. So theoretical is what should happen given the sample space. Okay, so the formula for this would be number of desired outcomes divided by total number of outcomes. Empirical is when you are performing a simulation or experiment. It is what happens given the trials. Okay, so this is the number of successes over the number of trials. Okay, theoretical probability is what happens when you have the perfect environment, the perfect experiment, nothing's going to go wrong. Empirical probability is when you actually do the experiment, and in the experiment we have variables that we cannot always control. Okay? So we're not always going to get exactly what was desired when we thought about this in theory. Okay. The law of large numbers states that simulated or empirical probabilities tend to get closer to the true theoretical probability as the number of trials increase. So the more trials we have, the closer to the theoretical probability. Okay, so in this part here, we have probability P equals 0, probability P equals 0.5, and probability P is equal to 1. Remember, our probability can only equal what number? Up to 1. So if it is less than 0.5, we would say the event is less likely. Okay, if our probability is greater than 0.5, then the event is likely. Okay. If the probability is 0, this is when the event will not occur. Probability of 0.5 means the event is equally likely to occur or not occur. Makes sense, 50-50 chance, right? It can occur or it cannot occur. And probability of 1 means the event will occur. Okay, an example. After these notes, we're going to do an activity. That probability is 1. We will do that activity. It will occur. Probabilities can be written in forms of fractions, decimals, or percentages. For this class, we want to round them into decimals of 3 decimal places. Okay. So the first example says a bag contains 10 marbles, 2 black, 3 blue, 1 red, and 4 white. What is the probability that you will pull out a white marble? So remember, it's the number of successes. So how many white marbles are there? 4. Divided by the total number of outcomes. How many total marbles are there? 10. What's 4 divided by 10? 0.4. That's our probability. We have a 40% chance we will pull a white marble. Okay. What would be the proportion for blue marbles? 3 divided by 10, which is 0.3. 30% chance we pull a blue marble. Okay. The other example, it says, in the spinner below, each wedge is equal in this area. Why is it important to know they're all equal? Would we have the same probability if, let's say, the red wedges were larger than the yellow? No, so it's important that they're all equal so they have all the same probability. So it says, what is the probability the spinner will land on red? How many reds are there? 2. How many total wedges are there? 8. What's 2 divided by 8? 0.25. Next one, what is the probability that the spinner will land on yellow? How many yellows are there? 3. How many total wedges? 3 divided by 8? 0.375. right? 3 decimal places. Then we're going to talk about probability of a complement. The probability that an event does not occur is 1 minus the probability that it does occur. Okay? So if I look back up here and I look at this one right here. So this is the probability that we will land on red is 0.25. What would be the probability we don't land on red? It would be 1 minus 0.25, which is 0.75. Okay? So in order to find one that we don't need, we take the probability we have and subtract it from 1. That would be the complement of the probability. We write this in the formula P of not A is equal to 1 minus P of A. The notation for not A is A to the C power. Therefore, the formula is P of A to the C power is equal to 1 minus P of A. Remember, I said this unit is very math heavy. Okay? So if that's your strong suit, hopefully you like this unit. Okay? Sometimes it's easier to compute the complement than it is the event itself. So for example, a coin is flipped 3 times and the result of each flipped is noted. Okay? It says draw the sample space for this event. Okay, so we're flipping a coin 3 times. What is one possible occurrence that can happen? All heads. Okay, what's another occurrence that can happen? All tails. Okay, anything else? Good, it could be heads, tails, heads, which means the first one I flip is heads, the second one tails, the third one heads. And this continues for every single possibility. So we have tails, heads, 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 tails, 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 heads, tails, heads, tails, and head, tails, tails. Okay? Which means how many total occurrences can happen? 8. There's 8 total occurrences. Okay, so then we look at the questions. It says, what is the probability a series of 3 flips will produce exactly 1 head? So looking at each of these, how many have exactly 1 head? Exactly 1, which means only 1. 3, right? We have this one, and this one that have exactly 1 head, which means we would do 3 out of, how many total were there? 8. 3 out of 8. There was 8 sample spaces, 8 different ways that we could flip those 3 coins. So this gives us 0.375, which means there's about a 38% chance that when we flip all 3 coins, we'll get at least 1 heads. We'll produce exactly 1 head in each one. Then C says, what is the probability that a series of 3 flips will produce at least 1 head? Okay, so the first one is 1 head, which means only 1 head can happen. At least 1 head means more than 1 head can happen. So instead of going and calculating each one, we can do 1 minus the probability of no heads. Okay. How many in those instances have no heads? You're looking at this right here. How many have no heads? 1. So that means this is 1 minus 1 over 8 because only 1 out of 8 of them have no heads, okay, which would be equal to 7 over 8, which is 0.875. So approximately 88% probability that when you flip the coins, they will produce at least one head. There's only one instance where that would not happen, and that is when you flip the coin and they're all tails. Okay, it says, remember, probability answers the question, what would happen if I did this many times? Okay. The big thing here in this next part that talks about the myth of the law of averages is this bolded part. Future outcomes are not affected by past behavior. Okay. What that means is if you flip a coin and it lands on heads, does that mean the next time you flip a coin it will be tails? No, it's still a 50-50 chance of heads or tails. Okay. Now let's look at frequency tables. Okay, remember we learned about frequency tables back in Unit 1? Okay. Unit 2. Okay, and that is when we were describing two categorical variables. So here it says a group of 50 high school students are interviewed and were asked what their favorite leisure activity is. The results are in the table below. It wants you to find and interpret these probabilities. So A says, of all the individuals surveyed, what is the probability of picking a male whose favorite leisure activity is dance? So how many males were in dance? 2. And how many total students were there? 50. So that means that probability is 0.04. Okay. B, of all the individuals surveyed, what is the probability of picking a person whose favorite leisure activity is reading? So any person at all, and their favorite is reading. How many? 16 out of 50, which is 0.32. Okay. C says, of all the individuals, what is the probability of picking someone who does not consider dance their favorite activity? So instead of calculating that, we can do 1 minus the people who like dance. So how many people total like dance? 18 out of 50, which gives us 0.64. Okay, notice that's a lot easier than going to each one and doing 16 out of 50 plus 16 out of 50, when we could just subtract the probability of the event occurring from 1 to get the probability of the event does not occur. Okay, subtract 1. I knew that because it says does not consider dance. Okay, D, of all the females surveyed, what is the probability of choosing a female who likes reading? Okay, so now we're only looking at females. How many total females are there? 30. How many like to read? 8. So 8 over 30 is 0.267, which means about 27% of girls like to read. Okay. And then the last topic was the simulations. Okay, I will be posting this video going over it in depth, right? You're not just going to have the video that I posted the other day. The imitation of chance behavior based on a model that accurately reflects the situation is called a simulation. Okay. Simulations are usually done with a table of random digits, a calculator, random number generator, or a computer software, or in our case, what? Desmos. We would use the random number generator on Desmos. So it says, what is the probability that a student gets 6 out of 6 questions correct on a true or false quiz written in Greek? Okay, let's assume nobody knows Greek. Should the instructor be concerned about cheating? Perform a simulation using the 4-step process to answer this question. So the first process is to state, which means to identify the question we are answering. So the question is it possible to guess 6 out of 6 corrects true/false quiz. That's the question. The plan. So it says describe the tool you will use to conduct the simulation. Be clear about what values you are assigning to the outcomes and what you're doing each time you're performing a trial and what you're recording. Okay, so if they just guess, what do you think the probability would be of them guessing true or false? 50. So them guessing true/false would be a 3 out of 6 chance, which is 50%. Okay. It says using a random number generator, I will assign the values 1 as getting the question correct and 0 to incorrect. So assign 1 to correct and 0 to incorrect. Okay. Then generate 6 random numbers. So we're generating 6 random numbers of just 1s and 0s. Okay. This will count as 1 trial, and let's do this for 20 trials. So we would repeat 20 times. So let's say we actually do this simulation, and this is what happens. Okay, so this is the number correct, and this is the number of trials. Okay, so let's say on the first trial, they got 0 correct. Okay, on the second trial, they got 1 correct, and this is the data that they got when they did it on yours. Okay, we're going to do something similar with the activity we're about to do with the dice. Okay, and notice that when they were doing all their trials, did they ever get 6 out of 6? So for example, 6 once. No. So their conclusion is that no trials got 6 out of 6 correct by guessing. Which means the teacher should be suspicious if this happens, which means one of his students got a 100% on a Greek test without knowing Greek and then said, well, I just guessed. When we could do a trial saying after 20 trials, it's a little suspicious because we didn't get any that were correct. Okay?